Hello my scholars, you're welcome to my school YouTube channel. My name is Emmanuel, and in this video we'll be tackling JAMB past question for chemistry for the year 2000. Please don't go anywhere, stick around and we'll be right back. Welcome back to my school YouTube channel, and in this video, like I said earlier, we'll be tackling JAMB past question for chemistry in year 2000, and today we'll be looking at question 26 to question 50. Let's get to question number 26 now. Given that M is the mass of substance deposited in an electrolysis and Q the quantity of electricity consumed, then Faraday's law can be written as, this is just simply talking about Faraday's first law of electrolysis that looks at the relationship between the mass of a substance that is deposited at the electrode and the quantity of charge that is passing through, of electricity that is passing through at that particular time. The relationship between the mass of a substance is directly proportional to the charge that of the electricity that is passing through. It is directly proportional to charge. Let's move to the board and see what happens. So if the mass is directly proportional to the quantity, we're given that Q is the quantity, okay, of electricity that is consumed. So when we remove this proportionality sign, it becomes M equal to, so we represent this becomes M equal to ZQ. So which means that the proportionality sign is now equal to what? Q is directly proportional, mass is proportional to the quantity, and then mass is equal to Z times Q. So whether it's written this way or it's written this way, M is equal to QZ. Okay, that we have that. So let's look at our options. Okay, we have option A, B, C. This is Z over Q, Q over Z, Z over 2Q. Then from this, what we have there, from what we have, M is equal to QZ. So option D is the correct answer for this question. Question number 27 now. 0.46 gram of ethanol, when burnt, raised the temperature of 50 grams of water by 14.3 Kelvin. Calculate the heat of combustion of ethanol. Before we can calculate the heat of combustion of ethanol, we need to find out first what is the heat that is absorbed by the water. Okay, so we need to get that first. And to get that, heat absorbed by water is an endothermic reaction because heat is being absorbed into the system. Okay, so from the surrounding into the system, so it is an endothermic reaction. So in that case now, we need to find what the H is going to be. Okay, heat absorbed will be M times C times what? Times change in temperatures, which is mass that is given of the water multiplied by specific heat capacity of water, which is 4.2, multiplied by the temperature. Then we find again what is the number of moles of ethanol that is actually produced. Okay, then we will now divide the two. Let's move to the board so we can see what happens here. Okay, so heat absorbed by water is MC delta T, that's change in temperature. Okay, so the mass of water was given as 50 grams multiplied by specific capacity 4.2, then multiplied by 14.3, which is the change in temperature, Kelvin. By the time we multiply that, we have 3003.0 joules. Okay, so you can convert that actually to kilojoules. Okay, just divide this by 1000, we have 3.003 kilojoules. So that is the heat that is absorbed by water. So what is the number of moles now of ethanol that underwent, combustion? So we're given the mass of ethanol from the question to be 0.46 gram of ethanol was what was burnt, okay, during the reaction. So you know that number of moles, N, is actually equals to mass over molar mass. So mass was given as 0.46. Then the molar mass of ethanol, you can calculate that from your C2H5OH. So you just multiply, C is 12 times 2. Okay, I believe you should know how to go about that. Now C2H5OH, that's the formula for ethanol. So the molar mass is, this is 12, carbon is 12, okay, times 2, plus hydrogen is 1, times 5, plus oxygen is 16, then plus hydrogen is 1. So by the time you sum up all of this, you are going to have 46. Okay, so that's why we have molar mass of ethanol to be 46 here. So when you divide this by this, you have 0.01 mole. Okay, so now we want to find the heat of combustion of ethanol. It is an exothermic reaction, okay, because this process now, heat is going to be given up into the what? Into the environment, into the surrounding, from the system to the surrounding. Heat is evolved. So because of that, we have a negative value here. Okay, so heat absorbed by water, we got that to be 3.03. So we just have 3.003 divided by number of moles of ethanol was 0.01. So by the time you divide this 1, 2, 1, 2, so that should give us 300.3. Of course, don't forget it's a negative value. Okay, 300.3, negative 300.3. Okay, that is it's no longer kilojoules now, that's joules per mole per Kelvin. Okay, 300 kilojoules per mole. Kilojoules per mole. That's the unit, kilojoules per mole. So 300. Don't forget there's a negative value here because it is what? Heat of combustion of ethanol. It is an exothermic reaction. So this should be our answer. Negative 300.3 kilojoules per mole. Let's move to the screen and see what we have there. We have positive 3000, positive 300, negative 300, negative 3000. So from the answer we got, the correct answer is negative 300 kilojoules per mole. So this is the heat of combustion of ethanol, minus 300 kilojoules per mole. So the correct option is option C. Let's move on to question number 28 now. Powdered marble reacts faster with hydrochloric acid solution than the granular form because the powdered form has what? Is it more molecules, more atoms, larger surface area, relatively large mass. Of course, if you have the same quantity of a substance in powdered form and then the other one in granular, okay, the smaller the particles, the faster the rate of reaction, because the ones that are in granules, okay, the one that are in granules and the one that are in powder, they are not, the particles are not the same. Those in granular have particles that are bigger, okay, compared to powdered form. Those in powdered form, they are in smaller particles. So the reaction, it will be faster because the surface area, okay, of each of those particles is going to react speedily with what? Hydrochloric acid, because it spreads. It tends to, react on the surface of each of those molecules compared to this one. Okay, so we say that the larger the size, the larger the size, the surface area of the particular substance, powdered form, and then the faster the chemical reaction that is going to, or the rate of reaction that is going to take place. So among these options now, it is because the powdered form has a larger surface area, okay, compared to what? Granular form. Okay, that's why this one had to have a faster reaction compared to the one in the granular. So the correct answer is option C. The reason is because the powdered form has larger surface area than the one that is in granular form. So the correct option is option C, larger surface area. Question number 29. Nitrogen gas reacts with oxygen gas to give us 2 moles of nitrogen 2 oxide. Okay, you see delta H is positive 180.6. So the delta H, which is the change in enthalpy, shows that what? It is positive. So it means that it is an endothermic reaction. And then we are told that in the reaction above, increase in temperature will what? What does it mean? Is it increase the quantity of N2, increase in the yield of NO, decrease the yield of this, decrease the quantity of oxygen? So actually, according to Le Chatelier's principle, an increase in temperature or pressure or concentration tends to make the chemical equilibrium, okay, to shift. Okay, once there is an increase in any of those quantities, it will cause the equilibrium position to shift in order to what? To adjust and to cancel out the effect that is brought about by increase in that temperature or pressure or volume. So in this case now, we're told that increase in temperature, an endothermic reaction, what we look at is what? Delta H. Is it positive or negative? So for an endothermic reaction, a system in equilibrium will cause the equilibrium position to shift to the right, okay, thereby favoring the production or formation of what? Of the products, okay, because we have delta H here being positive, so it means it's an endothermic reaction. So if it's an endothermic reaction, increase in temperature is going to lead to an increase in the yield of the product. Okay, and in this case now the product is NO. So if you look at the option now, the increase in temperature will definitely, it's not going to increase the quantity of this because that's the reactant, but the product is actually NO. So it's going to increase, it's going to lead to increase in the yield of nitrogen 2 oxide. So the correct answer is option B, increase in the yield of NO. Let's move on to question number 30 now. For a reaction in equilibrium, the species involved in the equilibrium constant expression are. That means when a system is in equilibrium, we want to consider the equilibrium constant expression. You know, the substances that react could be in solid, could be in gaseous, could be in aqueous or in liquid form. Okay, so which one do we consider? Okay, when we have the reactant and then we have the product on the right hand side, usually we don't reckon with solid substances because the activity, okay, of solid substances is usually a unit. Okay, is 1. When we say unit is 1, so because of that, it does not have an effect on a system in equilibrium constant. Okay, so usually what we consider are always the gaseous substances and the aqueous, or those ones that are in dissolved species, are what we actually consider. Okay, not just the liquid, we look at the dissolved and then the dissolved substances or in solution, and those ones that are in gaseous state, in fluid state, so not the one in solid phase. So option A, we have gaseous and solid. Okay, gaseous is correct, but solid species we do not record with that when it comes to equilibrium constant expression. Liquid and solid species, no, we do not record with solid species. You can see that again. Solid and dissolved species, yes, this is correct, but solid is not. But gaseous and dissolved species. Okay, so we have option D is the correct answer. Question number 31. A phenomenon where an element exists in different forms in the same physical state is known as what? Where a phenomenon where an element exists in different forms in the same physical state is known as what? We have isomerism, we have amorphism, we have allotropy, we have isotopy. They all sound almost the same. Okay, isomerism is a situation where a substance or a compound actually exhibits, has the same molecular formula but different structural formula. Okay, so that is not it. Allotropy, isotopy is a situation where a substance or two or more atoms of an element actually have the same atomic number but different mass number. And then allotropy is a situation, or is a phenomenon, not a situation, it's a phenomenon where a particular element exists in different forms in the physical state. For instance, we have carbon has allotropes. Okay, the allotropes of carbons are usually graphite and diamond. Okay, we have sulfur, those are elements that exhibit allotropy. Okay, so the correct answer in this option now is option C. Allotropy is the right answer, because allotropy is the phenomenon where an element exists in different forms in the same physical state. That is what it is. So the correct answer is option C, allotropy. Now let's move over to question number 32. The substance often used for vulcanization of rubber is what? The question is, what is vulcanization? Vulcanization is a process whereby rubber is being heated, okay, with sulfur. Okay, why do we do that? In order just to increase the strength, okay, of that particular rubber. And then from the definition, you understand what the answer is here. Okay, though we have some other elements like tellurium, like selenium, that also are vulcanizing substances. But among these options that we have here now, the substance that is often used for vulcanization or heating of rubber, okay, to increase the strength is sulfur. So the correct answer here is option C. Sulfur is the correct answer. Do you know you can take practice questions with our simulated JAMB CBT past questions? All you need to do is to click on the link in the description below that takes you to the Myschool website, where you have opportunity to download the Myschool mobile app on your Android devices and the Myschool software on your laptops and computers. Please go ahead and start practicing. Now let's move on to question number 33. A gas that is not associated with global warming is, we have CO2, we have SO3, we have CH4, we have H2. H2 is hydrogen. Okay, so among all of this is associated with global warming. Okay, carbon dioxide or carbon dioxide, it is one of the gases that causes global warming, okay, or what we call greenhouse effect. Okay, we have SO3. Okay, we have methane. Methane is also a gas that is associated with global warming. All of these ones are associated. They are poisonous gases, okay, that can cause the depletion of the ozone layer. And then we have hydrogen. Hydrogen is not, okay. Hydrogen is just a gas but is not associated with global warming. So among these options that we are given, hydrogen gas is the correct answer, which is option D. I hope you are enjoying this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap the notification bell to keep you informed and notified once we upload our next video. Let's move on to question number 34. The refreshing and characteristic taste of soda water and other soft drinks is as a result of the presence in them of what? Carbon dioxide, carbon trioxide, soda, and glucose. Usually, we refer to soft drinks, okay, as carbonated drinks, okay? So carbonated drinks, so which means that it has some content of carbon. So elimination method of these options now, if it is carbonated drink, so it cannot be soda and it cannot be glucose, okay? So option C and D are stricken off. So we have between option A and B, carbon dioxide, carbon trioxide, because some drinks are referred to as carbonated drink because there is carbon, compound present in. So which one between these two now? Carbon trioxide, it's a poisonous gas, okay? So that definitely cannot be in the drink that will be consumed. So the correct answer is carbon dioxide, also known as CO2, okay? We call it carbon dioxide, so that's why we refer to it as carbonated drink. So the correct answer is option A, carbon dioxide. It gives the drink the refreshing taste when you take it, and then it also acts as a preservative for all the raw materials that are used in producing the gas. So the correct answer is option A, carbon dioxide. Question number 35. A form of carbon used for absorbing poisonous gases and purification of noble gases is for absorption. Any substance that will be used as absorption definitely has to have a porous surface, whereby it can be able to absorb, gases into it, and then to also purify. When it comes to purification, remember in water treatment we talk about activated carbon, as one of the diseases. So the type of charcoal among all of this one that has the characteristics of porosity of the surface and then that can purify also noble gases is activated carbon or activated charcoal, and it is usually produced from wood. So that is why we have this. So wood, ELM, actually has that characteristics, to form this activated carbon or activated charcoal that is used in purification of that. So it is gotten from wood charcoal, and the correct answer among these is option A, wood charcoal. Question number 36. Synthesis gas is a mixture of what? In other words, synthesis gas is also known as water gas, because it is used in the synthesis of methanol, and other hydrocarbons, So usually, synthesis gas are also known as water gas, and there it is a combination or is a mixture of carbon monoxide or carbon trioxide and hydrogen. That is what forms water gas, carbon monoxide and hydrogen. So if you look at the options we have here, this is methane and water, no. Methane and hydrogen, no. Carbon dioxide and hydrogen, no. Carbon trioxide or carbon monoxide and hydrogen. So the correct answer is option D. C looks like it's confusing actually, but option D is the correct answer. Carbon monoxide and hydrogen. That is what forms synthesis gas, or what we call water gas, CO and H2. So the correct answer is option D. Now let's move over to question number 37. Potassium vapor bonds with a what? When potassium is exposed to air, and then undergoes combustion, what happens? The electrons become excited, and then it moves from a ground level to an excited state. So once it does that, a color that is characteristics of potassium is actually produced, and usually it is a lilac color or what we call a violet color. So for potassium, it bonds with a flame that is violet in color or what we call lilac. So if you look at the option, blue flame is not, Brick red flame is not. Violet flame, then we have golden yellow flame. So the correct answer is option C. Violet flame is the correct answer. Question 38. A common characteristics of copper and silver in their usage as coinage metals is that they, remember, both of them are metals, okay? Both copper and silver. Even though copper is a transition metal, silver is not a transition metal, okay, for the first series, okay? But both of them are metals. And what we know about metals usually are that what? They are reducing agents. So if they are reducing agents, that means they are not easily what? Oxidized. They can act as oxidant in some reactions, but they are not easily oxidized because they are reducing agents. That's why they are used as coinage metals, okay? So if you look at option A, says they have high metallic luster. That is common to all metals, actually. So they are not easily oxidized. They are easily oxidized. Of course, they are not non-metals, so they are not easily oxidized, and they are not easily reduced. If we had an option that they are easily reduced, of course, we know that's the case for all metals, that all metals are reducing agents, okay? So the correct answer here is option B. They are not easily oxidized. Option B is the correct answer. Question number 39. Hematite is an ore of, this is a common question, okay? Hematite is an ore of ferrous, and ferrous is our what? Iron. So it is actually the oxide of iron, okay? So iron 2, so that is Fe2O3. That is what hematite is, Fe2O3. So that is the oxide of iron. So hematite is an ore of iron, not zinc, not lead, not copper. It's option C. So the correct answer is option C, iron. Question number 40. The least easily oxidized of the metals below is calcium, sodium, zinc, aluminum. Of course, this is having a valency of +3. This is +2, +1, +2. Actually, the order in which all these metals are reactive has to do with the activity series, okay? In the activity series, the chemical series, you look at how reactive each of the metals are. And if you look at the activity series properly, you discover that aluminum actually is greater, okay, in terms of reactivity. This one among these four, zinc, actually is the least among them, the least oxidized, that is easily oxidized among these four. This is higher than this in terms of reactivity, okay? So option C is the correct answer, zinc. Question number 41. The repeating unit in natural rubber is, when we say repeating unit, what compounds, okay, smaller unit or smaller compounds that combine together to form a larger one. In other words, we say monomers that combine together. Monomer is just the simplest form, the simplest unit, okay, that combine to form a larger, or what we call polymer, okay. For instance, we have glucose, okay, several glucose, okay, smaller unit that combine together in chains to form cellulose or to form starch, okay. We have them linked together by glycosidic bond. That is several units, okay, repeating units. So the same way we have repeating units of isoprene to form natural. So natural rubber is a polymer, okay, that is formed for smaller units of isoprene that are combined together, that are linked up together in chain. So isoprene is the repeating unit in natural rubber. Natural rubber, isoprene. So the correct answer is option B, isoprene. If you do have any questions that is bothering you, please feel free to ask your questions. You can do that by clicking on the link in the description below that takes you to the Myschool website. There, you can ask a question and solutions will be provided within the shortest period of time. Now, let's move on to the next question. Question number 42. Unsaturated organic compounds are identified by decolorization of. There's the characteristics of unsaturated organic compound. When we talk about unsaturated organic compounds, we are talking about the alkene and the alkynes, okay? Remember that the alkanes are saturated hydrocarbons, while alkene and alkynes are unsaturated hydrocarbons. So how do we test for the presence of unsaturated organic compounds? It is by decolorization of what? Option A, silver bromine and potassium tetraoxomanganate 7 solutions. We have bromine water and acidified potassium tetraoxomanganate 7 solution, silver bromide solution and bromine water and alkaline potassium tetraoxomanganate 7 solution. So if you look at these options now, bromine water usually gets decolorized, okay, and then there is also potassium tetraoxomanganate what 7 solution. So if you look at those options now, option A is not, option C is not, option B and D actually look similar, okay. Here we have acidified potassium tetraoxomanganate 7, here we have alkaline potassium tetraoxomanganate 7 solution. Option B should be the right answer because there's a double bond in this unsaturated hydrocarbon for alkane usually, so that double bond between the carbon will be broken down by the acidity. The hydrogen bond that is present here, the hydrogen ion that is here, that is what is going to make the bond to get broken up, okay. There's a bond between carbon oxygen double bond, okay, carbonyl group there, and thus once it does that, that is why there's a color change, that is there's a decolorization, okay, of the potassium tetraoxomanganate 7 solution. So it is acidified potassium tetraoxomanganate 7 solution. So these two, bromine water react with unsaturated hydrocarbon organic compound to get them decolorized, and then also acidified potassium tetraoxomanganate 7 solution is the answer. So the correct option here is option B, bromine water and acidified KMnO4. Do you have a better solution or explanation to the questions that have been solved? Please do well to share. All you need to do is just go to the comment section, indicate the question number and the solutions that you would like to share with us. Let's move on to question number 43. The conditions necessary for the extraction of a water molecule from 2 molecules of ethanol are from 2 molecules of ethanol. Extraction of a water molecule from 2 molecules of ethanol are, first of all, this reaction will take place in the presence of a concentrated sulfuric acid, that's H2SO4, okay. And apart from that, the temperature at which this reaction is going to take place is around 140 degrees Celsius, okay, to 170 degrees Celsius, which is a high temperature. And then we have also the ethanol has to be in excess, okay, excess ethanol solution, we have it. So for this kind of reaction now, the condition necessary for the extraction of a water molecule from 2 molecules of ethanol are, because there's going to be diethyl ether will be formed first before eventually this is extracted from the 2 molecules of ethanol, okay. So that there's an intermediate product, that's the diethyl ether that is gotten first before you eventually have that. So it requires a higher amount of energy, of temperature, to be able to achieve that, and then the acid has to be in excess. So with that, option A is less acid and lower temperature. No, that is not correct. Excess acid, yes, and a lower temperature, no, it is not a lower temperature because the temperature is quite high. Excess acid and a higher temperature, yes. Less acid and a higher temperature, no. Option C is the correct answer. Excess acid and a higher temperature. Question 44. The chlorinated alkane often used industrially to remove grease is, we have tetrachloromethane, chloromethane, trichloromethane, dichloromethane. All these are chlorinated alkanes, okay? These are reactions that are gotten from chlorination of alkanes. When you have CH4 methane, for instance, reacting with chlorine, Cl2, okay, under, of course, the situation, the condition is that it has to take place under the sunlight or ultraviolet, okay, radiation, okay, light. So the chlorinated, among all of this now, which one is actually used industrially to remove grease, okay? But among all of this now, the one that is used industrially to remove dirt, to remove grease, okay, industrially, is tetrachloromethane. So which means that CCl4, that is the formula. So the answer, or the correct answer, is option A, tetrachloromethane. Question 45. The reaction of carbide with water gives what? Okay, the common carbide, okay, is the calcium carbide actually, okay. So how do you put that? When you get to the panebiters, okay, those that will melt you know, the part of a car together. Maybe they want to melt some metallic ions together, that uses oxyacetylene flame. Okay, they use it. So when you get there, you see that on the floor we have something like white substances. Okay, that is your calcium carbide. So in the production, how do we get it? So it is just a reaction between ethine and water. When ethine reacts with water, calcium carbide is formed. In fact, the calcium carbide is used as explosives. Okay, in some places, just put set a fire, it can blow off, you know, so much. So the reaction of carbide with water gives what is going to give. Is it ethine, ethene, ethane, ethanol? Let's look at the board. Let's see what we have. This is your calcium carbide. Okay, of course, it's reversible. This is your ethine that you have here. So calcium carbide here reacts with water here to form, this is what? This is ethine. Okay, that's an alkyne with calcium hydroxide. So ethine is what eventually is produced here. So let's go back to the screen. We have the reaction of carbide with water gives ethine. That is C2H2, not ethene, not ethane, not ethanol. The correct answer is option A. Question 46. Alkanols are generally obtained by the oxidation of what? What reaction? We have different types of alkanols here: primary, secondary, tertiary, and alkanoic acid. Okay, of course it's not going to be alkanoic acid, because the oxidation of alkanols usually will produce alkanols. Okay, then the complete combustion or complete oxidation of alkanols is what gives us the alkanoic acid. Okay, but this is not complete. They are asked now that alkanols are generally, you know, if you oxidize alkanols or alkanols first, primary alkanols, you will get alkanols. Then on further oxidation, in the presence of acidified KMnO4, you are going to have alkanoic acid. Okay, but they are not asking us of alkanoic acid, we are asked of what? Alkanol. Alkanols are generally obtained by the oxidation of secondary alkanols. So secondary alkanols, when they undergo oxidation, okay, they are going to produce alkanols, okay, or your ketones. Those are what we call the ketones. Okay, they are going to produce. So the correct answer here is option B. Secondary alkanols. Oxidation of secondary alkanols will lead to what? Alkanols are produced in that way. So the correct option here is option B. Question 47. Sucrose is made up of what? You must understand that sucrose is a disaccharide. Okay, disaccharides are made up of, they are sugars or carbohydrates that are made up of monosaccharides, two monosaccharides combining together or reacting together to form. And we have, apart from sucrose, we have other disaccharides that are lactose, and then the other one that is maltose. Okay, so sucrose is usually a reaction between a glucose molecule and a fructose molecule. Okay, not option A is glucose and glucose. Glucose and glucose will react together to form maltose. Okay, glucose and fructose will react together to form sucrose. Fructose and fructose, of course, will not. It's not that. Then galactose and glucose. Okay, this is going to give us lactose. That's the milk sugar. Okay, so the glucose and fructose is what react together to give us sucrose. Okay, that's a sugar that we consume. So option B is the correct answer. Glucose and fructose. Option B. Question 48. This is a solubility curve. It says the diagram above is the solubility curve of a solute X. Find the amount of X deposited when 500 cm cube of a solution of X is cooled from 60 degrees Celsius to 20 degrees Celsius. So all we need to do first is we are going to trace what is 60 degree at this point. This is the temperature on this, and this is the solubility. Then we extrapolate. Okay, if we have at this point, this is 60 degree. When you trace it to the point where this curve is, try to extrapolate at this point to somewhere around here, and that is, this is 4, here is 5, so half of that is 5.5. So which means at 60 degrees, that is 5.5 mole per dm cube. Then the temperature, the other temperature is 20 degrees Celsius. So you come here again, you trace 20 here, and then you extrapolate here, this is 4 degrees. So at 20 degrees, that is 4.0. So the difference between them now, so let's move to the board now so we can see what happens here. So solubility at 60 degrees, as we saw it from that curve, is 5.5 mole per dm cube. The solubility at 20 degrees is 4.0 mole per dm cube. Okay, so we should actually find the difference between them because there's a change in temperature. So the solubility, that is going to definitely affect the solubility of that solvent, solute X. So 5.5 minus 4.0, that is 1.5 mole per dm cube. So that is the solubility. But remember that solubility is the number of moles of the solute multiplied by 1000 divided by volume of the solvent. Okay, the solvent here is the water. If you look at the question, were we told if it is water? Okay, they didn't tell us it was water, but they told us that it deposited in 500 cm cube of a solution, okay, of X that is cooled at that. So the solvent here is having a temperature of what? Of 500 cm cube. So we just substitute the values for what we have. So for solubility already, we are going to make use of this because that's the difference between that at the same temperature. So solubility will be 1.5 will be equal to number of moles. That's what we have to find. We have to find the amount, okay, the amount which is also equal to number of moles times 1000 divided by the volume of solvent from the question is 500 cm cube. So if you cancel this goes here, 1 here, that is 2. So we have 1.5 equal to n times 2. So we can change this to 3 over 2, of course, or you can use your calculator to punch, then whatever thing you have. So this is 1.5 is the same as 3 over 2. So this is 2n over 1. So by the time you cross multiply, you have 2 times 2n, that will be 4n equal to 3. So divide both sides by 4, n will be equal to 3 over 4, which is equal to 0.750 moles. So let's look at the options. Let's go back to the screen. We have we have option A, 0.750 mole, 0.950 moles, 2.375, 4.750 mole. For what we just solved, the answer is option A, 0.750 mole. Question 49. Use the option above to answer this question. The graph that describes a zero order reaction is. We have the first option A, we have option B, we have option C, option C. In reaction rates, okay, usually rate is usually equal to K, okay, then times the concentration of X. Okay, depending on that for the first order reaction. Okay, let's move over to the board so you can see for a zero order reaction. Okay, the relationship between concentration and time, we give a graph that comes down. It is a straight line graph, but it is coming down. Okay, that is the relation between concentration and time. But when you are looking at the relation between the rate and the concentration now, it's going to be a kind of uniform, okay, like a straight line, uniform a line that moves this way, because at this time and the rate remains constant. You can see it going this way. So as the rate is constant, what type of concentration continues to get what? Continue to increase. As the concentration increases, the rate remains constant. That's why we see this coming down this way. Okay, so this is for a zero order reaction. For a first order reaction, you can see this is a curve that we have this way, okay, but it is coming straight down, then eventually it now curves. Okay, then if you look at that now, this is rate, and then this is concentration. Okay, if you are looking at it the other way around. So what happens? This is a straight line graph that passes through the origin. Okay, so when you see a straight line graph that passes through the origin this way, this is a first order reaction. Then you look at the second order, you can see this one curves directly from here and keeps on going this way. So this should go this way. Okay, and then you have this relationship between rate and concentration will be, you can see the way it goes this way and then it moves that way like a curve. Okay, so just get familiarized with the with the graphs. Rate, concentration for a zero order is a straight line this way, but because it shows that the rate remains constant, okay, as the concentration is increasing. But for this now, as if you extrapolate this, so that means as rate is increasing, concentration is increasing. So this is what? Directly proportional. to each other. As rate increases, concentration is also increasing, so it passes through the origin. But for this, you can see it moves on here, it comes here, then it begins to what? To increase. The concentration begins to increase, and then the rate also begins to increase. It's uniform here first for zero order. So if you look at this now, for zero order, you have this. For first order, you have this. And for, so let's move over to the screen and let's see. We are asked to find the one that describes the zero order reaction. For what we just saw now, this is what? For first order. You can see it passing through the origin. As rate is increasing, concentration increases too, okay? Then this one is actually for zero order. You can see the rate remains constant as concentration increases. So option B is the right answer. Option B is the right answer. Question number 50 now. The compound above is an what? You can see we have CH3, we have CH2, we have a carbonyl group here between carbon and oxygen, okay, double bond. Then we have oxygen, CH2, CH3, okay. So the compound above is an what? Is it an ether? Is it an ester? Is it an alkanal? Is it an alkanol? Alkanol, okay. Usually alkanal we just have a CHO, okay, ending it. So this is not a CHO. Esters we have, usually we will have an alkyl group, okay. Then we have a COO here, okay, to show that it is actually an alkanoid. Then we have another alkyl group here. I think this one actually fits in for an ester. We have CH3CH2. This is an alkyl group. Then we have COO here. You can see that. Then we have CH2CH3 here for this. So this is another. We have a prime here because it is a different alkyl group from this, but actually I think both of them are actually the same, but just to show that this is the first one, this is also the second one. So this is CH3 CH2. If you write that, it will be CH3 CH2 COO CH2 CH3. So that is actually an alkanoid, which is an ester. And you know, esters, they have a sweet smelling, you know, fragrance, okay, odor that we usually have. So the compound above is an ester. Option B is the correct answer. I hope you enjoyed this content. If yes, please don't forget to click the like button, hit the subscribe button, and finally tap the notification bell to keep you notified once we upload our next video.